Myself, Dr. K. Hemalatha, Associate Professor. I am working in Marri Laxman Reddy Institute of Technology and Management. So, today I will discuss my topic name is dielectric materials. So, in this dielectric materials, contents of the course. So, first of all, we have to discuss introduction and some basic definition and types of polarization and internal fields in the solids and Clausius and Massuti equation and piezoelectric materials and ferroelectric materials and ferroelectric materials and applications of the dielectric materials. These are all the topics we have to discuss in this unit. And next, so first we have to let us introduction to the dielectric materials. First, you know about the what are the differences between the dielectric materials and insulators. So what are the differences between dielectrics and insulators? So coming to this one, first of all, so what is the meaning by insulators? Already you know about that, right? So insulators are nothing but which materials in the solids, which materials have the large energy gap. So energy gap is nothing but the distance between the valency and conduction band, in which materials the energy gap is more. So that materials are called the insulators. So in these insulators the conductivity is very poor. Okay, so coming into the insulators, so the substance which have low conductivity and which create obstruction the flow of current is known as the insulators. But what is the meaning by dielectrics? So the dielectrics is nothing but the minimum loss of energy, in the presence of the electric field. In the presence of the electric field can be developed with the minimum loss of the energy is known as the dielectric materials. So simply you can say the one statement is in the presence of the electric field, some dipoles are created in which insulating materials, that materials are called the dielectrics. So simply you can say the dielectric materials is nothing but insulators only. But in insulators, some materials are in the presence of the electric field, it shows some different kind of property. So that is nothing but it produces the dipoles in the presence of the electric field. These insulating materials are called the dielectric materials. So simply you can say that the dielectric materials are nothing but insulators. All dielectric materials are called the insulators, but all insulators are not dielectrics. Okay, so first of all you have to discuss some differences between the insulators and dielectrics. So next coming to the point is in the insulating materials you don't observe the polarization. So in the presence of the electric field, in the dielectric materials you observe the polarize. And coming into the bond formation, so in the insulators we have to observe the covalent bond. In the dielectric materials weakly bounded as compared to the insulating materials. And coming into the dielectric strength, in the insulating material it is very low, and in the dielectric materials the dielectric strength is high. And the charges, so coming to the charges, the obstruction to the charges in the insulators and in the dielectric materials the charges are storage, so store the charges. And next, the examples of the insulators are cotton, plastic and mica, etc. And coming into the examples of the dielectric materials are dialyzer and vacuum, and next distilled water, etc. So these are all the examples of dielectric materials. So and what are the applications of the insulators? So coming into the applications, the conducting wires in high voltage systems. So in these cases we have to use the insulators. And coming into the dielectric materials, so where we are used these dielectric materials is capacitors and power cable, etc. So these are all the differences between the insulators and dielectrics. And next slide. So what is the, so now, so brief introduction about the dielectric materials. So dielectrics are basically non-conductors of electricity. So dielectric materials are basically non-conductors of electricity. So these materials do not contain any free charge carriers in the conduction. So in these dielectric materials do not have the free electronic charges. So they have the positive and negative charges are tightly bounded together. In the presence of the electric field, the positive and negative charges are tightly bounded together. And under the mainly these dielectric materials, they exhibit this dielectric property. So compulsory you have to maintain external electric field. External electric field. In the presence of the external electric field only, the charge carriers of dielectrics are affected. What is meaning by that one means, so here we have to consider one atom. Okay, so this is the equilibrium atom. So it is the positive and negative charges of the positions are equilibrium. So whenever, so here E is equal to 0, that means there is no electric field in this case. So whenever we have to apply the electric field, that means E is greater than 0. So these positions are changes. That means, for example, you have to apply the electric field is in this direction, then the positive charge is, it is stay in the same position, but the electric field is nothing but you have to apply the negative charge, right? So these, whenever you have to apply the electric field, all the electron cloud, so what is the atom means, you know that, right? So this is the nucleus. Around the nucleus the electrons are revolving. So whenever we have to apply the electric field, so the electric field is negative and electrons have the negative charge. So both are repel. Then what happens? Then these electron cloud. So one is called the electron, but so many electrons are there. Simply you can call the electron cloud. So these electron cloud is repel opposite direction to the electric field. So this is called the dipole. So what we have observed here, positive and negative charges are displaced from their equilibrium position. They form the electric dipoles. So this is called the electric dipoles. In the definitions also we have to discuss the electric dipoles. So electric dipole is nothing but two equal and opposite charges are displaced. Some distance is called the dipole. That is called the electric dipole. In the presence of the electric field, the dipoles are created. So these kind of materials are called the dielectric materials, which have responsible for the dielectric behavior of these materials. Okay, these are all we have to observe in the presence of the electric field only. This is about the some points. And next, so the dielectric materials. So you have to observe the dielectrics may be solids or liquids and gases also. The main function of dielectric material is, so what is the purpose of dielectric materials? Why you have to use in the dielectric material? The main purpose is to store the electrical energy, in the presence of the electric field. Whenever you have to apply the electric field, some dipoles are created. Due to that one, electrical charges are stored. So while the function of insulator is to obstruct the flow of current. And next point, dielectrics are non-metallic materials of high specific resistance. These dielectric materials are non-metallic materials of high specific resistance. And the electrical conductivity of the dielectric materials is very low. And that are the examples are glass, plastic and mica, etc. So these are all the some points about the dielectric materials. And next, so the dielectric materials are also two types. One is the polar molecules, and next one is the non-polar molecules. What is the difference between the polar and non-polar molecules? So polar molecules is nothing but in that dielectric materials already the dipoles are existed. In which materials, in which insulating materials already the dipoles are existed in that material, that type of materials are called the polar molecules. In these molecules, what we have to observe? Permanent electric dipole. Already dipoles are existing, and these polar materials are, its polarization is temperature dependent. That means these polar molecules are depend on the temperature. And next, coming about the non-polar molecules. So non-polar molecules is nothing but induced electric dipoles. Induced electric dipoles. So we have to induce that electric dipoles in the presence of the electric field, and the polarization is, its polarization is temperature independent. Non-polar molecules are not depend on the temperature, but polar molecules are depend on the temperature. And next, coming about, so these are all the examples of the polar and non-polar molecules. HCl and H2O and NH3, these are all the polar molecules. And coming about the non-polar are N2CO2 and CCl4. So these are all the polar and non-polar dielectric materials. And next, so what are the types of the dielectric materials? So already I said, so the three types of the dielectric materials are there. One is the solid, and another one is the liquid, and another one is the gases. So first coming into the solids, one is the ceramics and plastic and glasses. So these are all coming about to the solid dielectric materials. And liquid dielectric materials, mineral oils and synthetic fluids and water. So these are all the example of the liquid dielectric materials. And the next one is the gaseous molecules. In the gaseous molecules, air and SF6 and nitrogen. So these are all the types of the dielectric materials, solids and liquids and gases, and some examples. So these are all the types of the dielectric materials. So now we have to discuss some basic definitions about the dielectric materials. So these definitions are very important. Whenever you have to understand these definitions only, so next coming topic is very easily. So first definition is the dipole. So what is the meaning by dipole? Means a set of two equal and opposite charges. A set of two equal and opposite charges are separated by some distance. Two equal and opposite means positive and negative. The charge value is same, but charges are opposite. The two equal and opposite charges are separated by some distance is called the dipole. Dipole is nothing but two equal and opposite charges are separated by some distance is called the dipole. So this is one of the definition. And the next definition is very important. So the dipole moment. This dipole moment you have to indicate with the letter mu. Okay. So it's, what is the meaning by dipole moment is the product of charge and distance. The product of charge and distance in a dipole. The product of charge and distance in a dipole is called the dipole moment. So the charge is Q. Equal and opposite charges, right? So the charge is Q and the distance of the distance of these two charges separated by distance, right? This is the D. So the product of charge into distance is called the dipole moment. Dipole moment. The units of this one dipole moment is coulomb centimeter. Coulomb centimeter. Mu is equal to Q into D. So where Q is the charge and D is the distance between these two charges. And the next coming definition is dielectric constant. Dielectric constant, or you can call other name is relative permittivity. Relative permittivity. So we have to specify this relative permittivity with the symbol of epsilon suffix R. Epsilon suffix R. And you have to call another name is the dielectric constant also. And coming about this definition is the dielectric, this is the dielectric characteristics of the material are denoted by this dielectric constant. So the characteristics of this dielectric material, we have to specify very important this one, relative permittivity. Relative permittivity with the, you have to indicate with the symbol of epsilon R. And next, the dielectric constant. The dielectric constant, what is the definition is? The dielectric constant of a medium as the ratio of permittivity of the medium and permittivity of the free space. So what is the definition of this? Dielectric constant of the medium is defined as the ratio of permittivity of the medium. We have to specify with the symbol of epsilon, the medium's permittivity and permittivity of the free space. Permittivity of the free space. We have to specify with the symbol of epsilon naught, the ratio between these two. So epsilon R is equal to epsilon by epsilon naught. So this is called the ratio between the material permittivity to free space permittivity, the medium permittivity to free space permittivity. This is called the relative permittivity, or you have to call the another name is dielectric constant. Dielectric constant. So these are all the some definitions. And another definition name is polarization. Polarization. This is very important. So yeah. So whenever we have to, the dielectric is placed in the presence of the electric field, we have to apply the external electric field. The positive and negative charges are displaced. The positive and negative charges are displaced from their equilibrium position. From their equilibrium position by very small distances together. So very small distances throughout the volume of the dielectric medium. Throughout the volume of the dielectric medium. That means, so whenever you have to apply the, so this you have to observe this one. So without electric field, so there is no polarization. So without electric field, the electrons and nucleus, electrons cloud and nucleus are equilibrium position. Whenever you have to apply the electric field, then what happens? The all are oriented along the field direction. All positive charges are oriented along the field direction. So thus dipoles are produced. So the process of producing electric dipoles which are oriented along the field direction is called the polarization in the dielectrics. So especially what is the meaning by polarization? It is the basic definition of the dielectric materials are exhibit the property in the presence of the electric field only. Whenever you have to apply the electric field, then what happens? All atoms or molecules are, it is in equilibrium position without electric field. Whenever you have to apply the electric field, what happens? So along the field direction, the positive charge is placed, the negative charge is repelled opposite to the field direction. then that is called the electric dipoles. In the presence of the electric field, means you have to apply the external electric field, the dipoles are created. So this process is called the polarization. So how we have to define this polarization means, so the dipole moment, the polarization is defined as dipole moment per unit volume, okay. Polarization you have to specify with the letter P, okay. P is equal to dipole moment per unit volume. Is called the polarization. So what are the units for the polarization? Dipole moment units are coulomb per centimeter or meter. So say coulomb per meters by volume means meter cube. So meter is cancelled. Then what is the polarization units are? Coulomb per meter square. So this is the polarization. P is equal to mu by V. Units are coulomb per meter square. And so we have to specify another definition of about this polarization is if the number of molecules per unit volume. So in the per unit volume, the number of molecules or atoms, the value is capital N, okay. Then and each of the momentum, the dipole momentum is mu, okay. So the total polarization P is equal to, have to specify N into mu. So this is also definition of the polarization, okay. Polarization is nothing but mu by V. That means the dipole moment per unit volume of the area, per unit of volume, and the dipole moment per unit volume, the number of molecules are capital N. Then you have to specify the polarization is each molecule, the dipole momentum is mu. Then the polarization P is equal to N into mu. So this is about the polarization. So polarization you have to specify or indicate with the letter P. And the next definition. And what is the next definition? Polarizability. This is also very important definition. So please understand this definition. And what is the polarization means? We have to specify with the symbol of alpha. So what is the meaning by polarizability means? When electric field is applied to the solid, the electric charges are displaced, causing polarization in it. Already we have just explained, right? So in the presence of the electric field, the dipoles are created. These induced dipole moment is directly proportional to the we have to apply the external field, electric field, right? So that electric field, the induced dipole momentum mu is directly proportional to the external electric field. So this is the relation between the induced dipole momentum. Means, so we have to increase the electric field, automatically the electric dipoles are also increases. So the dipole momentum is directly proportional to the electric field. So this is the mu is directly proportional to the E. So we have to remove the proportionality. We have to specify one constant, that is the alpha. So here this is the proportional constant and this one is the polarizability. You have to remove the proportionality. You have to specify the constant is alpha. This is the proportional. This is the alpha. Okay. We don't confuse. So mu is directly proportional to the E. You have to remove this proportionality. You have to taken one constant. Mu is equal to alpha E. That means the dipole momentum is increases. When it is increases, you have to increase the electric field. Okay, the induced dipole momentum is increases means we have to increase the electric field also. It is decreases means we have to apply the low electric field. Then automatically the induced dipole momentum is also decreases. And you have to remove the proportionality. You get one constant, mu is equal to alpha E. So this alpha is called the polarizability. This alpha is called the polarizability. The total polarization of dielectric containing n number of atoms is given by P is equal to, just we have discussed, right? P is equal to n mu. So in the mu place we have to write alpha E. P is equal to n alpha E. So this is also polarization, another definition. So using polarizability, we have to specify the alpha also. So polarizability means, what is the polarizability means? The dielectric momentum is directly proportional to the electric field. So mu is equal to alpha into E. So we have to substitute this mu value in this definition. In this definition, what is the polarization? Another definition is n mu. That mu place we have to substitute n alpha E. N into alpha E. This is the mu place. Okay. So P is equal to n alpha E. So this is also polarization. So this is very important definition. And next another one is the susceptibility, electric susceptibility. So this susceptibility you have to indicate the Xi. So what is the electric susceptibility means? It is defined as the ratio of number of electric lines of force due to internal field. The number of electric lines of force due to internal field and the number of electric lines of force due to external field. So this ratio is called the electric susceptibility. This is very important parameter. So psi is equal to the number of electric lines of force due to internal field to the number of electric lines of force due to external field. So this ratio is called the electric susceptibility. Then susceptibility is equal to P by epsilon into E. So this is the electric susceptibility. And next definition. This is also very important definition. And what is that one? Electric induction, or you have to call other name is electric displacement. This is you have to indicate with the letter D. It is defined as the number of electric lines of force passing through per unit area of the dielectric medium. So the electric induction is nothing but it is defined as the number of electric lines of passing through per unit area of the dielectric medium is called the electric displacement or electric induction. So these electric displacement, you have to call another name is, you have to call the electric displacement vector also. So this I have to indicate with the letter D. For an dielectric medium is defined as, so here also dielectric displacement D is equal to epsilon into E. Here in the epsilon place, just to already we have discussed, right? Epsilon r is equal to epsilon by epsilon naught. So now epsilon is equal to epsilon naught into epsilon r. So in the epsilon place we have to write epsilon naught into epsilon r. Then electric displacement D is equal to epsilon naught into epsilon r into E. So here E is the electric field strength. So hence the permittivity of the medium can be defined as the ratio of the electric induction D and electric field intensity. So you have to specify the relative permittivity of the medium epsilon. You have to define another definition is D by E. So D is the electric field induction and E is the electric field intensity. Okay, so this is about the electric field induction, or you have to call the electric displacement. So this is the very important definition. And the relation between the D and E and P. D means electric displacement vector, E is the electric field strength, and P is the polarization. So we have to the relation is D is equal to epsilon naught into E plus P. So in the D place you have to write epsilon naught into epsilon R. E is equal to epsilon naught E plus P. So P is equal to, this value is moved this side, P is equal to epsilon naught into epsilon R minus 1 into E. So what is the susceptibility? Psi is equal to P by epsilon naught into E. You have to substitute this value in this susceptibility. Then you have to get epsilon naught into epsilon R minus 1. The susceptibility is equal to epsilon naught into epsilon R minus 1. So here epsilon R means relative permittivity is greater than 1. So since epsilon R is greater than 1, okay, then that means the susceptibility of any material is always positive. The susceptibility of any dielectric material is always positive. So this is the relation between the D, E and P. Yeah, so these are all I got these all top contents in this reference books. I have to use these references, and so in next session we have to discuss another topics. Thank you.